This is Mr. McCord's ICP class, Unit 6. What we're going to be demonstrating is combustion reactions using ethyl alcohol, also known as ethanol, that is poisoned with methyl alcohol or methanol. This is our ethanol here. Its chemical formula is C2H6O. And our methanol is right here. This is CH4O. We'll have a little bit in a flask like this. We will shake it up to get our ethanol and methanol to vaporize a little bit, and we're going to ignite the gas above the liquid. Right? We should get a combustion reaction, which you might be able to guess, should be some kind of burning. We'll get a flame, right? A release of energy that shows that a chemical reaction is happening, that things are becoming more stable as these chemicals react and turn into something else. Now, what they turn into can be predicted by the fact that this is a combustion reaction. So in our chemical reaction equation, whether we're using methanol or ethanol, both of these have C's and H's. They're going to react with O2, and they should make CO2 and H2O. This is our O2. It will be with our carbon and hydrogen-rich compound on the left side of the reaction equation, on the reactant side, and on the product side on the right, we should have CO2, carbon dioxide, and H2O, water. Okay? The number of molecules, number of particles of our reactants that it takes to make a certain number of particles of these guys without losing any atoms and without gaining any atoms, keeping everything conserved, mass and energy, depends on how we balance the reaction equation. In this reaction, both ethanol and methanol are going to combust by reacting with O2 gas. And we're going to show what that looks like in the lab. So we're going to take a little bit of ethanol, pour it into this Erlenmeyer flask, and we don't need much because, again, the vapor, the gas phase of this ethanol and methanol is where we're going to be burning best. Since gases take up way more space than the liquid that they come from when they evaporate or boil off, I don't need all that much liquid to get this reaction to go well. Now, to get enough vapor to fill the flask to get this reaction to go efficiently, I'm going to cap this with a rubber stopper. I'm going to shake this up, swirl it around, make sure that we've got plenty of vapor to combust, to burn with the oxygen that's already in the air. Take the stopper off. I have moved the ethanol, methanol, and whatever else that's combustible far away so that I don't have any runaway reactions. And to kickstart the reaction between our ethanol, methanol, and the oxygen that's already in the air, I just need to use something like this, a lighter, to kind of give a little bit of energy at the beginning to get everything moving. All right. Now, this demonstration is done this way, in a flask, and a small scale to keep things safe. But if we want the wow factor of this, we can step it up a little bit. So let's do a bigger version of this reaction with another carbon-containing and hydrogen-containing compound, rubbing alcohol, which is C3H8O. Follows the similar kind of setup of methanol and ethanol, but isopropanol, or isopropyl alcohol, or rubbing alcohol, has a little bit more to react with in that vapor. Let's try it. Now again, since this is going to be a combustion reaction, the reaction equation should look very similar because it's following the same reaction type, the same pattern. The rubbing alcohol that we have here is C3H8O. We're going to react it with O2 gas that's in the air. And just like with the combustion reactions before, when this reaction happens, the products that we make are CO2 and H2O. We just balance the equation from there to make sure we're making the right amount of this and that. Instead of using a tiny Erlenmeyer flask, we're stepping up to this big old glass container here. Again, compared to the amount of gas that I'm going to make to actually burn, the amount of liquid I need is not all that much. I move the container to make sure it's far away from this so I don't have any chemical reactions run away from this. And just like with the Erlenmeyer flask, I need to swirl this around to make sure I've got plenty of vapor inside this container. All right, I think that should be good. Now, I'm going to shut the lights off for this one, and we'll see how this reaction goes.